The top of liquid changing into a gas. Evaporation. Evaporation is when a liquid turns into a gas, usually from the surface, when heat causes its molecules to move faster and break away.
Imagine sitting in a crowded room, and gradually people start leaving one by one, making the room feel less congested. This is similar to how molecules at the surface of a liquid gain enough energy to escape into the air as gas, reducing the overall density of the liquid at the top. Just like people leaving a crowded room makes it less crowded, molecules escaping from the surface of a liquid into the air make the liquid level decrease, illustrating the process of evaporation.
Water in the form of a gas. Water vapor. Water vapor is the gaseous state of water that is part of the water cycle.
Imagine you're trying to find your missing keys in a cluttered room. Just like how the keys are somewhere in the mess but not immediately visible, water vapor is water in a gaseous state that's present in the air but not directly seen. In this analogy, the rune represents the atmosphere. The clutter is the air filled with various elements, and the hidden keys symbolize water vapor, present and impactful, yet not immediately apparent to the naked eye.
The process of a gas changing into a liquid. Condensation. Condensation is when water vapor in the air cools down and turns back into droplets, like on a cold glass.
Imagine trying to fit too many clothes into a small suitcase before a trip. As you pack, the clothes get compressed and squeezed tightly to fit into the limited space, much like gas molecules cool down and come closer together to form a liquid. Just as the clothes change from a loose pile to a compact bundle in the suitcase, gas molecules transition from a freely moving state to a denser liquid form during condensation.
Water that falls to earth in any form, like rain, snow, sleet, or hail. Precipitation. Precipitation is when water from clouds falls to the ground as rain, snow, or ice.
Imagine you're at a party with a variety of drinks being served, but you're not sure what you'll end up with in your glass. Just like the uncertainty of which drink you'll receive, precipitation involves different forms of water falling from the sky, such as rain, snow, sleet, or hail. The connection is that just as a party guest might receive any beverage from the selection, the Earth can receive any type of precipitation depending on the atmospheric conditions, with temperature and air pressure acting like the bartender, deciding what gets served.
The constant movement of water through Earth and its atmosphere by evaporation, condensation, and precipitation. Water cycle. The water cycle is the journey water takes as it changes form and moves from the ground to the sky and back again.
Imagine you're trying to manage a wardrobe that's always overflowing with clothes, yet you can't seem to find the right outfit when you need it. This scenario is similar to the water cycle, where water continuously moves through its various stages. Just like your clothes cycle through different states of being worn, washed, and stored. In both cases, there's a constant flow. Evaporation is like taking clothes out to wear. Condensation is like washing and drying them. And precipitation is like putting them back in the wardrobe, ready to be cycled through again.
A storage area for fresh water. Reservoir. A reservoir is a large natural or artificial lake used to store water for various uses like drinking, irrigation, or power generation.
Imagine your smartphone battery draining faster than you'd like throughout the day. Just as you manage your phone's battery life by charging it during downtime to ensure you have enough power when needed, a reservoir stores fresh water during times of abundance to ensure there's enough supply during dry periods. The connection here is that both a smartphone battery and a reservoir act as storage solutions, one for energy and the other for water, helping us manage and distribute their resources efficiently based on demand and availability.
Rain and melted snow that is stored in underground soil and rock. Groundwater. Groundwater is the water found beneath the Earth's surface in spaces between soil and rocks.
Imagine trying to keep your house cool on a hot summer day by using thick curtains to block out the sun. Just as those curtains absorb and store the sunlight's heat, preventing it from making your house uncomfortably warm, groundwater acts similarly by storing rain and melted snow within the underground soil and rock. In this analogy, the thick curtains represent the underground layers of soil and rock that absorb and retain the water, while the sunlight represents the rain and melted snow being captured and stored for future use, keeping the environment balanced and hydrated.
A water-containing underground layer of rock. Aquifer. An aquifer is like an underground sponge that stores and provides water.
Imagine trying to find a lost sock in a packed drawer full of clothes. Just like how you have to sift through layers of clothing to find that sock, an aquifer is like a hidden water source tucked away beneath layers of soil and rock underground. In both cases, the sock and the water are valuable resources that are concealed within layers, requiring some effort to reach, but are essential once found.
A land area from which water drains into a river system. Watershed. A watershed is the area of land where all the water flows into the same river or stream.
Imagine trying to gather all the toys scattered around your living room into a single toy box. Just like how you need to collect each toy and bring it to one central location, a watershed functions by collecting all the water from the surrounding land area and channeling it into a river system. In this analogy, the toys represent water from different parts of the land. The living room is the watershed, and the toy box is the river system where everything ultimately converges.
The process of cleaning and restoring a damaged ecosystem. Reclamation. In simple terms, reclamation is the act of making damaged land or ecosystems healthy and usable again.
Imagine your living room is cluttered with various items like books, clothes, and random gadgets tossed around, making it difficult to move around or relax. Restoring order to your living room by sorting, cleaning, and organizing everything is similar to the process of reclamation in a damaged ecosystem. Just as you would carefully remove misplaced items, clean the surfaces, and restore order to make your space functional and pleasant again, reclamation involves removing pollutants, repairing damage, and reintroducing native species to bring an ecosystem back to a healthy and balanced state.
The careful management and use of resources. Conservation. Conservation in science is about protecting and preserving natural resources to ensure they are available for future generations.
Imagine you have a limited amount of phone battery left and you're not near a charger. Just as you carefully decide which apps to use and reduce screen brightness to make your battery last longer, conservation involves managing resources like energy or water to ensure they aren't depleted too quickly. In both cases, whether it's battery life or natural resources, the key is to prioritize usage and minimize waste to prolong availability, highlighting the importance of careful management.
The top surface of underground water. Water table. The water table is the upper level of groundwater in soil or rock, where the ground is saturated with water.
Imagine trying to fill a sponge with water, only to find that after a certain point, all the water starts pooling on the surface instead of being absorbed. This situation is similar to how the water table works, where the ground can only absorb so much water before reaching a point where it can't hold any more, and the excess water remains at the top. In this analogy, the sponge represents the ground, the absorbed water represents underground water, and the pooled water on the surface symbolizes the water table, which is the top surface of this underground saturation.
The movement of streams of ocean water. Ocean current. Ocean current is the continuous flow of water in the ocean, driven by wind, temperature, and salinity differences.
Imagine trying to navigate through a crowded shopping mall during a big sale, where everyone seems to be moving in different directions, but there's a general flow guiding the crowd. This scenario is similar to the movement of ocean currents, which are like invisible paths in the water, guiding marine life and ships. Just as the flow of people in the mall is influenced by the layout of the store and the attractions drawing them in, ocean currents are shaped by factors like wind, the Earth's rotation, and the coastline, creating organized streams that direct water movement across the globe.
The amount of salt dissolved in water. Salinity. It is the measure of how much salt is present in a given amount of water.
Imagine trying to dissolve sugar into your morning coffee, but realizing there's just too much sugar for the amount of liquid in your cup. This is similar to the concept of salinity, where the focus is on how much salt is dissolved in a given amount of water. Just as the coffee can only hold a certain amount of sugar before it becomes oversaturated and leaves sugar undissolved, water can only dissolve a specific amount of salt before it reaches its salinity limit. Highlighting the balance between the amount of solute, sugar or salt, and the solvent, coffee or water,